the concept of a cylinder. The concept of a cylinder. And first of all, cylinder is a three-dimensional figure which has two circular parallel base and then joined by a curved surface. Alright. So this is how a cylinder looks like. Okay, it has two parallel circular base. So these are the two parallel bases, and it has a circular base. Curved surface is also there. So this is how a cylinder looks like. So today we are going to look at the curved surface area of the cylinder. We will look at also the volume of the cylinder. Alright. So let's look at the curved surface area of the cylinder. And when you look at the cylinder, you see, we may have a cylinder where one side is closed and the other side is open. We can also have a cylinder where both ends are open, or both ends are also closed. Okay, so first of all, we look at the curved surface area, and then you look at the area of the cylinder when one side is closed, and then we look at its area when both ends are also both ends are closed. Then also look at the volume of the cylinder. All right. So with the cylinder, we will have the height. Okay. So our height is h, and since it has a circular base, we will have the radius. So we have our radius here, and then we have our radius here, and then we will have the same. Our height is also here. So this is our cylinder, because it has a circular base. This is our radius from the center to the circumference, and then we also have our height. Okay, so let's look at the curved surface area of the cylinder. The curved surface area. So we are going to look at the curved surface area. That is the area excluding the circular bases. All right, so we exclude here, and we just look at the curved surface area, just the area around the cylinder. Okay, and what we should take note is that this is very, very simple, and there is no need of memorizing a lot of formulas on a cylinder. What is very, very important is to understand the concept of what a cylinder is, and I know that it will be very simple for you to solve question on cylinder. All right, so when you look at the curved surface area of the cylinder, the cylinder the curved surface has a circular shape. All right, it has a circular shape, so it is like this. Okay. So since it has a circular shape, when you go around a circle like this, it is what? It is the circumference of the circle. Okay. So if you go around the cylinder, then it means that you have gone what? Round a full circle, which is the circumference. And then note that the cylinder has a height. So since it has a height, then if I want the curved surface area, the curved surface is a circle multiplied by what? The height of the cylinder. So the curved surface area become what? 2 pi r, where the 2 pi r is the circumference, because going around the circle is what? Is you have gone around the entire 360 degrees of a circle, which is the circumference of a circle, and then the cylinder definitely has a height, so you multiply by the height. So our curved surface area becomes 2 pi r h, 2 pi r h, and that is the curved surface area of a cylinder. All right, that is the area around the cylinder. Around, when you go around, you have gone the circumference of a circle, which is 2 pi r, and then you multiply by the height, because the cylinder has a height. So simple. So the circumference times the height of the cylinder. All right, so that is the curved surface area of the cylinder. Okay, the next thing we are going to do is to find the area of the cylinder with one side closed or one side open. So if one side is closed, definitely one side is going to be what? Is going to be open. So we are going to find the total surface area of the cylinder with one side open or one side closed. So what is happening is that if I open one side, then one side is closed, or if I close one side, then the other side is definitely open. So we are finding the total surface area of a cylinder with one side open or one side closed. All right. So if one side is closed, we know that the base of the cylinder, okay, is what? It has a circular base. So here is a circle, here is a circle. So if I'm looking at this total surface area of a cylinder with one side open or one side closed, then that would be the curved surface area plus the area which is what, or the side which is what, which is closed. So let's assume that this side is closed and this side is open. So I'll find the curved surface area, which is 2 pi RH, plus the side which is what, which is closed. So it becomes, what is the curved surface area? That is 2 pi RH plus the side that is closed. All right. The side that is closed is a circular base. And what is the area of a circle? That is pi r squared. So the total surface area of a cylinder with one side open or closed becomes 2 pi RH plus pi r squared, where 2 pi RH is the curved surface area plus the side that is what? That is closed. Okay, so here we can even factorize. And then what can we factorize? We have pi r here. So we can factorize pi r out. Then we have what? 2h, all right, plus r. So when we factorize pi r out, we have pi r into brackets 2h plus r. So that when we get 2 pi r h plus pi r squared. So this is total surface area of a cylinder with one side open or one side closed. I believe you get it. All right. Then let's also look at the total surface area of a cylinder with both sides closed. Or sometimes we say it's a solid cylinder. So when we say it's a solid cylinder, then what we are referring to that with the cylinder, both sides are out, both sides are closed. So we are going to look at the total surface area of a cylinder with both sides closed, or we can say a solid cylinder. So if it's a solid cylinder, then it means that both sides are out, both sides are closed. All right. So the total surface area of a cylinder with both sides closed, or the total surface area of a solid cylinder. Okay. So then that will be the curved surface area of the cylinder plus the two ends that are closed. And we know that the base is what? It's a circle. So we will have 2 pi r squared. Pi r squared plus pi r squared, and that will give us 2 pi r squared. The curved surface area is 2 pi r h plus the two ends that are closed, and then that will be 2 pi r squared. 2 pi r squared. So we have 2 pi r h plus 2 pi r squared. The curved surface area plus the two circular ends that are out, that are closed. And we can also factorize out. What can we factorize out here? We can factorize 2 pi r, and we have h plus r. H plus r. So 2 pi r h plus 2 pi r squared. So this is also the total surface area of a cylinder with both sides closed, or a solid cylinder. All right. So I think that this is so simple, and it's not something that necessarily needs to be memorized. It is just you have to understand, and when you understand, it is easy to write the formulas down. Is that okay? Okay. Then what we will look at is the volume. So that we look at the volume. So we look at the volume of the cylinder. And we have said that for a three-dimensional figure, each volume is the base area multiplied by the height. Okay, so what is the base area of a cylinder? The cylinder has a circular base, so that is pi r squared. That is the area of the base multiplied by the height. So the volume of a cylinder is pi r squared h. Pi r squared h. So this is about a cylinder. This is about a cylinder. And I think this is all that we have to know. We will go and solve some examples on a cylinder, and then I believe you definitely understand.